Hello there. Today I want to try to go over how to figure out a maximum or minimum when you're given a problem similar to a word problem of you have a area you need to enclose with a fence. Now, if you knew calculus, you could do this kind of easily by using derivatives. Now, I'm assuming that most people don't know calculus, but at least you know algebra, or at least you know some manipulation of equations. So let me actually give an example of when to do this. I'm going to bust out my big board here so we can see exactly what's going on. So, the big board. So, we have, let's say a barn here or some kind of wall. And then we have our garden, which we'll put right here. We want to enclose this garden, but we can use a wall. One of the walls of the barn is a wall. So we just have to make a rectangle here with the fencing. So we got fencing. We got wavy picket fencing here. Now, we want to figure out how to do that with the maximum area, which makes sense. We want the most that we can fill in, but we only have 80 feet of fencing here. So the way we have to think about this, we have a formula for area. Now, this is a rectangle, which makes it a little bit easier because the formula for area is very easy. It's just length times width. Makes it easy. This will be our length, and that'll be our width. So far, so good. The other thing we know, because normally in an algebra problem they would say, well, your length is twice your width, or your length. Well, here it doesn't give us any way to relate the two. It just says that we have a total, let's say, of 80 feet altogether, and we want to have maximum. Well, that still gives us a relationship, though. Because if you add up from here to here to here to here, that's our perimeter. That's our amount on the outside. So in this case, our perimeter is, well, we have a W, an L, and another W. So it's 2W plus L is the amount all the way around, which we were told in the problem we only have 80 feet. So that's our perimeter here. Now, will that help us? It will, because if you notice with our area formula, bringing that back over here, our area formula has a length and a width. However, to solve for that, we only have to get rid of one variable. So we only have to have an L or a W. Well, notice in our second equation down here, we have L and W equals a number. So we can actually solve for L here. Now, if you look at our equation here, and let me erase this, so we only have our equations with our numbers, we have a 2W and an L. You could solve for either one and it would be perfectly correct. However, if you think about what would be easier here would be solving for L. If you solve for W, we're going to have to divide by 2. That means we could end up, in this case, we would end up with fractions. That adds complications. Now, to solve for L here, notice that these two are added together. So we have to do the opposite and subtract 2W from both sides. So it'll give us L is equal to 80 minus 2W. So this gives us our relationship between our two variables. Notice that we have an L up here and an L down here. So now we can substitute it in. So we have area equals, but instead of writing the L there, I'm going to write that expression 80 minus 2W times W. So we have that right there. Now, the next thing is that we have to look at. We have to now distribute that through. Normally, it's better to flatten equations if you can. So if we distribute this through, we'll have 80W minus 2W squared. Normally, I like to write the highest power first, just by convention. So we have our area is equal to minus 2W squared plus 80W. Now, there are two ways you can go from this point. The first way is a procedure called completing the square. That, in my mind, is a complicated procedure. Nothing wrong with it. It is a little complicated. The other method, which is a little bit easier but unfortunately requires you to memorize or to know a formula, tells us that when you have a quadratic, which is what we have here, we have a squared is our highest power, and we have a W in there. When we find that, that means to find our location of where it happens, not necessarily what our highest area is, but where it happens at negative b over 2a. Now, all of a sudden I have a's and b's here, and where are they in the formula? If you think back to dealing with quadratics, this is a generic formula. It looks like ax squared plus bx plus c. Now, if you've done quadratic formula, you recognize the a, b, and c's are just the numbers out in front of what we have here. B is the number out in front of your w. A is the number in front of your w squared. In this case, the number in front of your w is 80. And that negative stays out there as part of the formula. And that 2 is part of the formula. And now we have to put in our a, which is negative 2. So, to simplify that, keep the 80 up there. So now we have 2 times negative 2, which is negative 4. Remember, we still have that negative out in front. So we have 80 divided by negative 4 is negative 20. Double negatives cancel out, so that just leaves us with a 20. So our width here is 20 feet. So now we know our width, we can figure out our length. Remember, our length, going back to this formula, is just 80 minus 2w. Well, it's 80 minus 2 times 20. 2 times 20. Remember, please excuse my idea around Sally. Purple eggplants make delicious afternoon snacks. So we do order of operations, and we find our length here is 40. Well, if we know our length is 40, and we know our length is 20, area, if you remember going back, again, notice that once we find W, we're kind of going back here. It's just length times width, or we know 40 times 20. 40 times 20 is 800. So knowing that, we know that our area, our maximum area that we can fill here is 800 square feet, and our length is 40, and our width is 20. Now, great thing about this video is you can always rewind. If you have any comments, go below. You can always hit the subscribe button as I put more math videos up. You can always double check on that. If you have any requests, also put it either in the comments or in the channel comments, and I will answer them as soon as I can. Thanks so much, and I'll talk to you later.